College Algebra, Module 7, Section 7.2, Part 2. This is a continuation of Module 7, Section 7.2. Objective 5, the rational zero test. Let f of x be the function a sub n x to the n plus a sub 2x squared plus a sub 1x plus a sub 0, which is the same one we've always had, where a sub n is not 0. Represent a polynomial function with integer coefficients. If p over q is a rational number written in lowest terms, and if p over q is a 0 of the function f, then p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. What that means is, if you take your polynomial and you look at the first term and the last term, factors of a sub n is what this formula refers to as p. Factors of the leading coefficient a sub n is what this rule talks about for q. So they said all possible rational zeros are of the form p over q. So let's do an example. List all possible rational zeros of the function f of x equals 11x to the fourth plus 13x to the third minus 42x squared minus 52x minus 8. Well, the first term, these are our q factors, and the only numbers that will divide evenly into 11 are positive or negative 1 or positive and negative 11. P would be factors of this last term of negative 8, so factors would be positive or negative 1, positive or negative 2, positive or negative 4, or positive or negative 8. So all possible rational zeros are of the form p over q, which means it's plus or minus 1 over plus or minus 1, plus or minus 2 over plus or minus 1, and it's everything in our p list over 1, and everything in our p list divided by 11, because we have to consider all the factors of p divided by all the factors of q. So if we simplified this, positive or negative 1 divided by positive or negative 1 is just positive or negative 1. Positive or negative 2 divided by positive or negative 1 would be positive or negative 2. Same thing for 4 and 8. Then the next piece would just be positive or negative 1 over 11, positive or negative 2 over 11, positive or negative 4 over 11, and positive or negative 8 over 11. Remember, these are just possible zeros that are rational numbers. Let's do another one. This time, we're not just asked to find the possible rational zeros, we're asked to find the rational zeros. Do you remember the list we had from the previous page? Okay, here's our list. So one option is to just go through and try all of these. Since our highest power is 4, we're looking for 4 solutions. Remember, they could be the same solutions, they could be imaginary solutions, so we don't really know. But what we could do is we could just start trying. So let's say we did synthetic division by 1. That would be 11, 13, negative 42, negative 52, and negative 8. So when we start our synthetic division, this shows that positive 1 is not a 0. Well, let's try negative 1. Okay, well when we try negative 1, so we got a remainder of 0, which says that x plus 1 is a factor, and so is 11x to the third plus 2x to the second minus 44x minus 8, because that was what we just had left over when we did the division. Well, now we've got to do it again. We're still looking for 3 more solutions. Well, our possible rational zeros are still factors of 8 over factors of 11, so our list has not changed yet. So let's just pick another one. Let's try 2. When we try 2, this time we're using the result. We don't have to go back to the original problem. When we try 2, you notice we get a remainder of 0, which now tells us that x minus 2 is also a factor. So we had x plus 1 a factor from the first try. If 2 is a 0, then x minus 2 is going to be the next factor. And then we've got a remaining factor of 11x squared plus 44x plus 4. So our question is, can we factor that? Well, it's a trinomial of degree 2, so let's try it. We've got 11x and x. Last two have to multiply to give us 4. So if we tried 4 and 1, that would give us 11x and 4x, which would not work. If we switch that around and put 1 and 4, that would give us 44x and 1x, which is not going to work. So if we go through and do 11x and x and do 2 and 2, that would give us 22x and 2x, which is 24x. That didn't factor either. Because this doesn't factor, that means there are no rational zeros of this polynomial. So our only two rational zeros are -1 and +2. Objective 6 is finding all real zeros. So let's do another one. Find the zeros of the function f of x equals x to the third plus 2x squared minus 1. Now notice this one is not just find the rational zeros, but it is find the zeros. So we're going to start out with our possible rational zeros, which are factors of the last number, which would be positive or -1, divided by factors of the first number, which is also positive or -1. So our possible rational zeros are just 1 or -1. So let's try it. Synthetic division says try it by 1. Remember, we start with our highest power, so there's 1x to the third. 2x squared, there's no x's, and then a -1. So when we do synthetic division, which gives us a remainder of 2, therefore 1 does not work. Let's try -1. So that means -1 is a 0, which means x plus 1 is a factor, and so is x squared plus x minus 1. Now the question is, can we factor further? Well, we've got to factor that. Well, that actually will not factor because there's nothing that will multiply to give you -1 that will add to give you a +1. So at this point what we have to do is go in and solve this piece using our quadratic formula. So we've got a equals 1, b equals 1, and c equals -1. Now remember your quadratic formula, -b plus or minus the square root of b squared minus 4ac over 2a. So that would be -1 plus or minus the square root of 1 squared minus 4 times 1 times -1 divided by 2 times 1, which would be -1 plus or minus the square root of 1 plus 4 divided by 2, which would give us -1 plus or minus the square root of 5 over 2. So when it comes to finding our zeros, x plus 1 was a factor, so -1 is a 0. The other factor had zeros of -1 plus the square root of 5 over 2 and -1 minus the square root of 5 over 2. So these would be our three real zeros. Now if we wanted to check this, we could go into our calculator, go to y equals, enter our function. When we graph that, we see that it does cross the x-axis in, it looks like 2 places. So let's zoom in just a little bit and look at that. Let's go to zoom 2 and press enter. Notice we have 3 different zeros. Each one of them crosses through, so they're all odd multiplicities, which means we've got 3 zeros that all have a multiplicity of 1. Now if we wanted to check it, we could do second trace number 5, enter, 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 and that gives us an intersection at 0.618. Well, just to check the numbers that we got down here, -1 plus the second square root of 5, close the square root, let's get an answer for the top, divided by 2. There is our 0.618 number, so I would safely assume that we are correct. Okay, let's do another one. Find the zeros of f of x equals 10x to the 4th plus 7x to the 3rd minus 27x squared plus 2x plus 8. Again, we can look at this because the highest power is 4. We are looking for 4 solutions. If we looked at possible rational zeros, it would be factors of 8, which would be positive or negative 1, positive or negative 2, positive or negative 4, positive or negative 8, divided by factors of the 10, which would be positive or negative 1, 2, 5, and 10. Notice we would still have quite a few of numbers to go through and choose. One way that we could use our calculator to help us to identify or eliminate some of these, we've got positive or negative 1, 2, 4, 8, 1/2, 1/5, 1/10. 2 over 1 is just 2. It's already listed. 2 over 2 is 1. It's already listed. 2 over 5, we need to add that one to our list. 2 over 10 is 1/5. That one's already listed. 4 over 1 is listed. 4 over 2 is 2. We need to consider 4/5 and 4/10. Well, 4/10 is just 2/5. That one's already listed. 8's already listed. 8 over 2 is 4. And then we would also have 8 over 5 and 8 over 10. But 8 over 10 is 4/5. So this is our list of possible rational zeros that we would have to try and do or try to use to factor to get something that's a little more manageable. Well, what we can do on our calculator is enter this polynomial, and then when we look at our graph, it appears that we would have 4 different real solutions. One here, and then 2 down here as this one crosses in. We could zoom in a little bit, zoom to enter. So that shows all 4 rational zeros. So then what we need to do is we can just sort of start eliminating. This first one right here looks like -2, so let's do synthetic by -2. So that's what we thought would happen, is -2 is a 0. So what that does is bring us down to, this is 10x to the 3rd. So let's see if we can find another one. If we look over here on our graph, it looks like 1 might work. So let's use that same answer row and do it by 1. Remainder is 0. So there's another 0 that works. This time the remaining factor is 10x squared minus 3x minus 4. Now these other 2 zeros look like they are not nice integers. So what we can try to do is factor this. So our factored form would be x plus 2, x minus 1, 5x minus 4, and 2x plus 1. So that would give us -2, 1. If you set 5x minus 4 to 0, you're going to add 4 divided by 5, so that would give us 4/5. If 2x plus 1 is equal to 0, we're going to subtract 1 from both sides, divide by 2, which would give us -1/2. So that would be our 4 zeros of this function. Now this one just says approximate the zeros of the function round to the nearest hundredths. So we're not even going to do the rational zero test or the synthetic division. So we're going to go in and type in our function. I'm going to go ahead and do zoom 6. Notice we can see all three real zeros. So to find them, we're going to go second trace, which is calculate, number 5, enter for the first curve, enter for the second curve. We don't want to guess. So our first zero is at 0.12257598. Rounded to the nearest hundredth would be 0.12. Our next intersection, second trace, number 5, enter, enter. This time we'll go over here to this first one, and that says that the second intersection is negative 1.8957, or rounded to the nearest hundredth would be 1.90. Still have one more to go. Second trace, number 5, enter, enter. Remember, on guess you put your cursor closest to the one you're trying to find, and that would be 3.873142 or 3.87, and that would be our three real zeros. Objective 7, solving polynomial equations. The methods to solve a polynomial equation are the same as the method to find zeros of the polynomial functions. Each polynomial equation can be written in the form f of x equals 0, where f of x is a polynomial function. The zeros of f are the same things as the solutions of the equations. So to solve this equation, 6x to the third plus 22x squared plus 10x minus 6 equals 0, we're going to do exactly the same thing. We know there's probably 3 solutions. We could go through and try to find the rational zeros first. Well, it's factors of 6 over factors of 6, so it's positive or negative 1, 2, 3, or 6. Divided by positive or negative 1, 2, 3, or 6. So we can just start guessing, or we could pull it up on our calculator and see if it'll give us an idea of where to start. And graph that, we see our 3 real solutions. Well, looking at our graph, it looks like negative 3 might be a 0. So if we do synthetic by a negative 3, it shows that the remainder is 0. Therefore, negative 3 is a 0, or is a solution, which would give us 6x squared plus 4x minus 2 equals 0. So now we could take this and solve this quadratic equation, which I'm going to factor. I'm going to pull out a GCF of 2, which would give us 3x squared plus 2x minus 1. Factoring further, 3x and x, last two have to multiply to give us negative 1, so I'm going to do 1 and negative 1. And I want the 3x and 1x. We're trying to get a positive 2x, so I'm going to put a positive with the 3x and a negative with the 1x. So what that means is negative 3 is already a 0, or a solution. The second solution, 3x minus 1 equals 0, add 1 to both sides, so we get 3x equals 1, which means x is 1/3. There's a second 0. And then x plus 1 equals 0. That means x is negative 1. So our 3 solutions would be negative 3, 1/3, and negative 1, which, looking at our graphs, you see that the graph crosses the x-axis at negative 3, negative 1, and 1/3. Let's do one more. Solve this equation round to the nearest hundredth if necessary. So anytime I'm seeing round, I'm thinking it's probably not going to factor. So we'll just go ahead and use our calculator to start with. X to the power of 4 minus 7x to the power of 2 plus 10. Graph that. We see our 4 real number zeros. So we're going to go through second trace, number 5, enter, enter. I'm just going to start back over here with the leftmost solution, and we get 2.236, which would give us negative 2.24. Then we're going to do it again. Second trace, number 5, enter, enter. This time we're going to move it to the second one, enter, and we get negative 1.41. Then the third one, second trace, number 5, enter, enter. Put your cursor on the third one, and we get positive 1.41. And then the last one, and we get 2.236 or 2.24. So that would be our solutions. Okay, last one. Our application says an insect population P in thousands per acre X days past May 31st is approximated by the function P of X equals 2x to the third minus 18x squared plus 46x, where x is between 0 and 6. Determine the dates when the insect population equaled 30,000 per acre. So what that means is the population is P, so we want to solve that equation when P is equal to 30. So we're going to have 30 is equal to 2x to the third minus 18x squared plus 46x. To solve this, we're going to set it equal to 0. So we're going to subtract 30 from both sides, and we're going to figure out how to solve this equation. Well, we could try doing it by factoring. We could factor out a 2 and divide both sides by 2. We'd get x to the third minus 9x squared plus 23x minus 15. Then when we divide both sides by 2, that 2 out there cancels. Still, we've got to solve the polynomial x to the third minus 9x squared plus 23x minus 15. I know that our possible rational zeros are factors of 15 over factors of 1, but again, I'm going to use my graph to get an idea of which possible rational zeros we want to use. Well, it looks on there that they're at 1, 3, and 5. We could check them. Second trace, number 5, enter, 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 and there's 1. Second trace, number 5, enter, enter, again there's 3. Second trace, number 5, enter, enter, and we were correct, so it would be 1, 3, and 5. So the dates when the insect population equaled 30,000 per acre were on days 1, 3, and 5, which is 1, 3, and 5 days past May 31st. So I would say that would be June 1st, June 3rd, and June 5th. This is the end of topic 7.2. You are now ready to do the homework for Module 7, topic 7.2 in my math lab. If you have any questions, let us know.